Hello, I hope you're having a great day. So, first things first, can plants learn? That's a problem we need to answer. Hi, I'm Victor, and this is Brianna, Jalen, and Sebastian. And we conducted an experiment in an attempt to answer the question, can plants learn? In this experiment, which was conducted from March 12th to March 20th of 2018, we started off the experiment by indicating a problem, stating a hypothesis, recording data from the experiment, making an analysis, and stating the conclusion. I hope you enjoy the video and let's get started.
Okay, so for our background, we researched that there were many different ways that we could have gone about the experiment through phototrophism, gravitrophism, and thigmotrophism. So we decided to test phototrophism, which is the ability for the plants to lean towards sunlight. This theory was discovered by Darwin, and we reconstructed his experiment to learn how he discovered how plants quote-unquote see. For the hypothesis, if the marigold buds are covered with caps, then they will not go towards the sunlight because the photoreceptors in the bud won't receive direct sunlight and therefore won't be set in the auxins that trigger the upward and outward growth of the flower. For our experimental design, our independent variable is the amount of sunlight received. Our dependent variable is the angle of the flower towards the sunlight. Our control are the capless marigolds. The constants are the time in the sun, amount of water, amount of space, size of seeds, and temperature. And we had 2 trials.
What are the materials that we need? You might be asking. They are as follows: egg carton, potting soil, 10 marigold seeds, protractor, water spray bottle, ruler, tape, marker, aluminum or tin foil. Next up, procedures. Step 1. Put 1/4 of an inch of potting soil in 10 of the pots where the eggs would normally go. Step 2. Put a marigold seed in each pot and cover with about 3/4 of an inch of potting soil. Step 3. Water each pod and make sure the soil is damp. Marigold seeds do not need to be watered every day. Step 4. When the plants reach 1.5 and an inch, place the caps over the stems of the 5 test plants. Cut small bits of foil out, enough to cover the top of the stem. Step 5. Let plants grow till the end of the week and with the ruler, measure each plant's height in centimeters. Step 6. Use a protractor and measure the angle of each plant stem perpendicular to the light source. Step 7. Record data.
When we look at the data, the plants with caps have significantly less growth and have little to no curvature compared to the plants without caps in the control group, which had a significant growth outward towards the sun. Before placing the caps on the marigolds, we noticed that they all grew upward in a steady and similar fashion. By the end of the week, the control group had grown significantly upwards and outwards towards the sun. The angle lined up with the sun at about 3 p.m. in the afternoon. The angles were significantly smaller than the experimental group. The capped marigolds had very little outward growth, and their angle in tangent to the sun remained close to 90 degrees, showing little to no change. The data and trends support our hypothesis. If the marigold buds are covered with caps, then they will not grow toward the sunlight because the photoreceptors in the bud won't receive direct sunlight, and therefore won't be sent the auxins that trigger the upward and outward growth of the flower. We know that phototrophic plants like the marigold secrete auxins to trigger upward and outward growth towards sunlight. The control was in full sunlight and the auxins were secreted in the part of the flower closest to the sunlight, which, over the week, caused the plant to lean towards the sun. The experiment group, however, remained fairly straight. The caps blocked the tips off from the sunlight, therefore the photoreceptors were never activated. The lack of auxins in the tip hinders the plant from growing outward because it has no way to make itself lean out. It usually does this by secreting auxins in the side of the tip that is closest to the light source, resulting in an imbalance at the top. Therefore, the plant leans over. With that being said, we can now confirm that the data supports our hypothesis. One problem we encountered during this experiment was that one of our trials got blown away. In the future, if we were able to do this again, we would probably be more careful and have even more trials to make the results even better.
Post-lab questions. Question 1. Identify the hormones responsible for the behavior you measured. The hormone auxin causes parts of the plant stem to grow at an accelerated rate and to grow towards the light. Question 2. Identify the structure and cell type responsible for secreting this hormone and describe how the cells responded to accomplish the behavior you measured. The tips of the growing shoots, which are the upward growing new growth from the seed germination, is the structure responsible for phototropism. The cell type responsible for secreting this hormone is the axillary bud. After 3 to 4 days, the magnolia plant starts to move towards the light. Question 3. Connection of your work to the podcast Smarty Plants. In the podcast Smarty Plants, the researcher looks into how plants respond to different environmental changes, like sound, wind, and being dropped. In this experiment, just like the plants in the researcher's experiment, they learned and adapted to the change of sunlight. When the plant senses an environmental change, they in turn change or quote-unquote make a decision to do one thing or another. Like in the experimenter's experiment, when the plants quote-unquote sensed the sunlight, they secreted the hormone auxin to promote accelerated growth towards the light in order to perform photosynthesis quicker. Question 4. Connection of your work to the podcast From Tree to Shining Tree. In the podcast From Tree to Shining Tree, the researcher looked into the forest beneath the forest, or the root system. The researcher found that even though the trees seem to be competing for resources on the surface, the roots are exchanging nutrients and assisting one another. The researchers also found that the trees are assisted by fungi in which they have a mutualistic relationship. This can be compared to the magnolia we experimented on because both the trees and magnolias use chemical cues and reactions to make decisions on after sensing something.